Hello friends, good morning everyone. Today I am going to explain about the superposition theorem. In this session I am going to explain about the superposition theorem, proof and how we can solve the problems on the superposition theorem. Now I am going to explain about the definition of the superposition theorem. Superposition theorem in any linear network containing bilateral linear impedances and energy sources. The current flowing in any element is the vectors sum of the current that are separately caused to flow in that element by each energy source. Means what? For example, I am going to take a small example on that one. This one is a resistance Z1, impedances Z2 and Z3. Right? What they have told that in any linear network, this is a linear network containing a bilateral linear impedances. These are the Z1, Z2 and Z3 are the impedances. Energy sources means supply voltage, positive, negative and positive and negative. Two sources I am going to take in this session, E1 and E2. These are the two voltage sources, energy sources, the current flowing in any element. This is the one element, the current is flowing in this element I1 and the current is flowing in this direction I2. These are the two current sources. Element is the vector sum of the current that are separately caused to flow in that element by each energy sources. For example, this one is a circuit, it is a different currents with the individual energy sources. Individual energy sources means first step I am going to take this energy, I want to short this one. I am going to short this one. This one is a individually take that one, it is equals to I1 equals to I1 dash plus I1 double dash. We can take it. The further explanation proof of the experiment I am going to explain. First, it is a statement of the superposition theorem. This is a statement of the superposition theorem. Yes, in any linear network containing the bilateral linear impedances, these are the impedances, energy source, that current flowing in any element is the vector sum of the current that are separately caused to flow in that element by each energy sources. Next, you can remove this one, you can short this one and you can take this one. E1 is short and E1 positive negative E2. E2 equals to I2 equals to I2 dash plus I2 double dash. You can take it. In the proof explanation, we can prove this one. And there are the three steps are there to prove the superposition theorem. Right. First one is consider one source at a time and others are removed. Only one source you can take that one. For example, this one is a resistor. Impedances Z1, Z2, Z3. What they have told? Only one source you can take that. I am going to take current I1. Yes, the current throw in this circuit, in the element, voltage across the element we can use that one. We can remove the one voltage. If the two voltage sources are there, you can just step will be two cases we can do that one. If the three sources are there, we can use the three cases. We can do that. We can solve that one. Right. Next it is a step 2. What they have done? Current in various resistance and their voltage drops due to this single source are cancelled. Means what? Here we can cancel the one source. Here I am going to remove the one more source. I am going to short the E1, E2. I am going to take I1 and I2. Right. Finally, the algebraic sum of current and the voltage drops over the resistor due to different sources is taken. Algebraic sum of what? Finally, the algebraic sum of current. This is the algebraic sum of current. For example, summation I can take it equal to I1 dash plus I1 double dash. Voltage drops over the resistor due to the different sources. I am going to explain. These are the three steps to solve the superposition theorem. Right? Yes, proof of the superposition theorem means proof of the superposition theorem. I have already explained about that one. It is two voltage sources, 1 and 2. The resistors, impedances R1, R2, R3 is the current flow Z1, Z3 and Z2, and the positive and negative, the current flow I2. This one is your I. If you calculate the I1 value, you can take it as a I1. I equals to I1, you can take that one. Next is a circuit equals to now I have referred to it as a impedances. AC sources I am going to take, that's why I am taking it as a Z1 is like that. Z1. Z3 and Z2. I am going to take, and here also are saying I am going to take this one. This is the symbol of the impedances. I1 dash equals to, I am going to remove the short the PP, I1 dash equals to Z3 and Z2. This one is here. This one is the current I1. First, we are going to study about the I1 double dash. I have already explained about the definition. It is the algebraic sum of the current. It is the individual voltage sources. Even it is the one more voltage sources shorted. Individual voltage sources we can take it and superimpose the currents. Superimposing the voltage. It is called as a superposition theorem. We have already studied the definition. First, I am going to solve the circuit. I am going to solve the circuit. How it works? Right. First means I equal to I1 dash plus I1 double dash. We have to do it. Right. First, I am going to study about the apply KVL law. In your previous video, I have explained about the KCL and the KVL laws. That's why I am going to explain about the KVL. Apply KVL of loop 1. This one is your loop 1. The current flow Z1, right? E1 and E2. These are the voltage sources. First, I am going to apply that. These are in this direction minus Z1 I1. Yes. Z3 is common. I1 minus I2 equals to the voltage, it is in negative E1, right? Minus Z1 I1 minus Z3 I1 minus or plus minus into minus plus Z3 I2 equals to minus C1. I am going to divide that I1 minus I1 bracket Z1 plus Z3 plus Z3 I2 equals to minus E1. This is your equation number 1. This equation is very helpful for your all the derivation. And the same way, apply KVL for loop 2. You apply the KVL law for loop 2. This one is a minus I2 Z2, correct? And minus Z3 I2 minus I1. Here it is we are taking the loop 2. It is the I2 minus I1. Right? I2 minus I1 equals to the current is flowing in this direction. It becomes a positive. It is a E2. Right? Now I am going to take that negative into negative positive. I1 Z3 minus I2 is common. Z2 plus Z3 equals to E2. This is your equation number 2. Now I am going to calculate the value of the I. I am going to calculate the I1 value. I am going to take it as a delta is a derivative of that. We are going to take that. It is a calculate the value of I using the matrix. Z1 you can take it one side, not Z1, I1 you can take it one side and I2 you can take it as a second. Means I1 value is one kade haakbeku, I2 value na ee side haakta matrix solution easier. Means I1 idare ಏನಿದೆ minus Z1 plus Z3. Right? I2 is a Z3. Correct? Matrix you have studied in your PUC. Right? Here I1 it is Z3 is there. I2 is minus Z2 2 plus Z3. Correct? We are going to solve that one. Cross. First, second, minus of that. Z1, Z3, minus get cancel, it becomes plus Z1, Z2, Z1, Z3, Z3, Z2, right, plus Z3 square, it is minus Z3. This plus Z3 and this minus Z3 get cancelled. You can get delta equals to Z1, Z2, Z1, Z3 and Z3, Z2. You can get the equation. Yes. Next is I am going to calculate the value of I1 dash. Not I1 dash, I1 equals to, if you are calculating the I1, you can make this one is a constant. Yes, this one you can make this one is a constant. You can take that. I2 is constant, means I1 is constant, that's why you can take the I2 value. Here you can calculate the voltage across this circuit. We can find it minus V1 E2 plus E2, right? Equation number 1 and equation number 2, right? E2, it's the same thing, you can put it common, Z3, Z1 plus Z2 is a minus, right? Again we can cross multiplication. V1 Z1 plus Z3 divided by delta. Divided by delta, we can make it. It is to calculate the value of I1 and I2, we can using through this derivative. That's why we can use it minus Z3 Z2. So Z3 V2, right? Can calculate Z1 Z2, Z1 Z3, Z3 Z2. This is equals to I1. I1 equals to, this is the equation, and next we are going to calculate the value of the I1 dash and the I1 double dash. Yes, we got a I1 equals to what? E1 Z1 plus Z3 minus Z3 E2 divided by Z1 Z2 Z1 Z3 and Z3 Z2. This will note this point, and next we are going to study about the I1 dash. If you calculate the I1 dash value, we can remove the case 1. We can remove the case 1 of, we have to short the one more voltage, individual voltage. We can take it for this circuit. Individual voltage is like the E1. We can take it E1. Again, we apply the same procedure. You can copy the what is that? Means it is the equation equation 1 we can write it directly. Apply KVL. Yes, previously I have explained about this one. It is a, you can copy that same equation 1. Apply KVL with 1. Equation 1 we can write it. What do you have? I1 equals to minus I1 equals to Z1 plus Z3, right? Plus Z3 I2 equals to minus V1. This is your equation 1. But apply KVL for loop 2 is different. Loop 2 is different. Right? Loop 2 is minus Z2 I2. ಇಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಸಪ್ಲೈ ಇರೋದಿಲ್ಲ, ಹಾಗಾಗಿ ಇಲ್ಲಿ ಮೈನಸ್ I2 minus I1, Z3 is common, equals to 0. 0 you can take it. Right? Now you can take it I1 Z3 plus minus I2 Z2 plus Z3 equals to 0. At the same procedure, what I have done to calculate the derivative value, delta equals to same. I1 ಈ ಸೈಡ್ ಬರಬೇಕು, I2 ಈ ಸೈಡ್ ಬರಬೇಕು, Z minus Z1 plus Z3. Why I am going to change this color? Because you can get it easily, right? Yes, delta equals to minus Z1 plus Z3, here is a Z3 I1 minus Z2 plus Z3. What we have got is a delta value, right? You can write it directly to that one. Delta equals to Z1 Z2 Z1 Z3 and Z2. Yes, this one is we got it in the delta. Now we can find out the value of I1 dash. I1 dash means it is the source we have removed of the to short the E2. That's why we can take it. In the previous session we can take it E1 and E2 both we have taken, but here we can just short the E2. That's why I am taking just E1. I am going to take that one. E2 is 0. Obviously you have to write it same right there. Copy and paste it. Z3 minus Z2 plus Z3. Yes, we can calculate minus into minus plus E1 Z2 plus Z3. It's a 4 divided by delta. You can take it, right? I1 dash equal to divided by Z1 Z3 and the Z3 Z2. You can take it. Now I am going to write it here. I1 dash equals to E1 Z2 plus Z3 4 divided by Z1 Z2 plus Z1 Z3 plus Z3 Z2. Only one source you have removed, that is E1 and you have to find out the I1 dash. Next, we are going to what will you do that one? We have to go to find out the value of I1 double dash. Yes, now we are going to solve the equation of the I1 double dash. Right? That time what we have to do? We have to remove this one, E1, and we have to join the E2. Right? We have to short the E1, we have to join the E2. Right? Apply KVL. See? Apply KVL. Apply KVL equals to U1 for U1. We are going to take that one. It is minus I1 Z1 minus Z3 I1 minus I2 equals to E1 is 0. Right. Next, minus I1 Z1 plus Z3 plus I2 Z3 equals to 0. And apply KVL for loop 2. You can write it equation 2. Equation 2. Right? Equation 2 you have already done at the to calculate the I1 value. That time you have calculated. You can use it. Right? Next. Now I am going to write directly of that one. I1 Z3 minus I2 Z2 plus Z2 equals to E1. Right? Delta value no need to calculate because we have done it 2 times. Directly I am going to write the I1 double dash. What we have to write in the previous E1 we have written, E2 is 0. Here it is a E2. Right? Sorry for that one. It is a E2. We are telling it is a E2. You have to take the 0 for E1 is 0 and E2 equals to 100. The same way I2 ಯಾಕಂದ್ರೆ I1 ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತದೆ. ಯಾಕಂದ್ರೆ ನಾವು ಕಂಡುಹಿಡಿತಾ ಇರೋದೇ I1 ವ್ಯಾಲ್ಯೂ ಇದ್ದಾಗ I1 ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತದೆ. ಹಾಗಾಗಿ ನಾವು I2 ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ತೀವಿ. ದಟ್ ಇಸ್ ಅ Z3 and minus Z2 Z3. This is cancelled. This is in the minus E3 Z3 divided by delta. Can you have to direct 3 into double dash equals to Z1 Z2 plus Z1 Z3 plus Z3. So now we can compare these 3 equations. 2, 3, 4, and this one is a 5. Alright. I1 equals to E1 Z1 plus Z3 minus Z3 E2. Right? Here you have to add this one. I1 equals to I1 dash plus I1 double dash equals to same. E1 Z2 plus Z3. This is common for everyone. This is a minus 3 Z3. Right? Z1 Z2, Z1 Z3, and Z3 Z2 common. Right? I1 equals to I1 dash plus I1 double dash. We have solved proof of the superposition theorem. Right? This is the superposition theorem we have calculated. At the same way, you have to calculate the I2 equals to I2 dash plus I2 double dash. This is for your homework. You have to solve it and send it a reply. What will come? Right? At the same way, you have to prove it. If you don't know that one, I will solve it in the next class. And I am going to explain, just give a hint for that one. With the I2 dash in the formula, delta is same. While you are calculating the I2 value, delta is same. I am going to solve, just a minute, I am going to solve it. Just directly I am going to solve. Make it fast, but you can see it. We have to calculate the value of the I2 is. I am going to take you that same process. Apply KVL for group 1. What you have got it for equation 1? I1 equals to Z1 plus Z3 plus I2 Z3 equals to minus E1. This is your equation 1. And equation 2, apply KVL. Group 2. What you have got? I1 Z3 minus I2 Z2 plus Z3 equals to E2. You have got it? Equation 2. Right, you have got it. But before session, what you have done is, you have done the equation of the I1 and I2. You have to write it here. But interchange the value of that one. Delta equals to same procedure. You have to do the same thing. Minus Z1 plus Z3. Same procedure. There is no any changes in delta to calculate. Minus Z1 and plus Z3 and Z3 minus Z2 plus Z3. While you are calculating Z1 Z2, Z1 Z3 Z3 Z2. Same delta is got it, but I1 dash you are calculating I2 dash equals to. Now, while you are shorting this voltage source, shorting the voltage source, it is there. But while you are calculating the I2 value, just I2 you are calculating, even and E2 what I just said, that time we are going to take that one, minus E1 plus E2. In the previous session you are calculating the I1 value, you have taken the Z3 and Z2 plus Z3 you have taken. In this session, you can correct I1 makes constant. Here, I2 makes constant. I2 you can take it as a constant, right? Means I2 makes constant means you can take the value of minus Z1 plus Z3 you have taken, and here you can take the Z3 value. Here you can take the Z3 value. What you will get? I2 equals to divided by delta. Right? What we have written? Minus E1 Z3 plus E2 Z1 plus Z3 divided by delta. Again, I will value minus E1 Z3 plus E2 equals to Z1 plus Z3 divided by Z1 Z2 Z1 Z2 Z3 Z2. We have write it I2 equals to, at the same way we have to take that I2 makes short, we can take it, take this. I2 constant इधर एक 0 रहता है, ये वाला निकल है, इसके अंदर this equation becomes 0, right? Delta हो गया here, I2 dash equals to now we have the I2 makes constant, we can take it. I1 value we have written. E1 is minus E1 is there. We have to write the minus Z1 plus Z3. This one is a 0 because we showed the E2 value. Right? Next we can take it as a Z3. Minus divided by delta E1 Z3 divided by Z1 Z2 Z1 Z2 Z3 Z2. This is the I2 dash. I2 double dash equals to what we have to write it? E1 is 0. This E1 is 0. Is closed. Even short marketing, it will open marketing. What you have to write? This one is 0. This one is 1. And minus Z1 plus Z3. Z3. This one is minus get cancel. Right? Next, what you have to write? 0 minus into minus, that minus plus Z1 Z3 Z1 plus Z3 divided by Z1 Z2 plus Z1 Z3 Z3 Z2. This one is what? I2 dash. I2 dash becomes minus minus same addition of E2 plus Z1 plus Z3, the Z1 delta is common, you can solve it. I2 equals to I2 dash plus I2 double dash. In this session I have used the superposition theorem. In your next session I am going to take it on the other session. I am going to take the problems on this superposition theorem. Thank you.